In the last video, we figured out how our sun appeared and where this sphere we are currently on came from. But I repeat, our planet was not immediately cozy with green grass and blue sky. 4,400,000,000 years ago, the Earth did not look at all like the planet we know today. It was hot and hostile. Its surface was destroyed by numerous meteorite impacts. But over time, important changes took place that allowed the planet to form, which subsequently made the Earth habitable. In this video, we explore a process called planetary differentiation, when the Earth began to cool and separate into different layers, as well as how the first oceans and atmosphere appeared. As you and I remember, our Earth looked like a huge hot stone ball. And to begin with, this ball needed to cool down. There was a huge amount of heat in the center of our Earth, which remained after collisions with asteroids and other bodies. The temperature on the surface could reach thousands of degrees Celsius. However, over time, the Earth began to cool gradually, and the first signs of differentiation became noticeable. It should be clear to everyone that when the planet cools, a solid layer appears, and the more it cools, the thicker the layer. The Earth began to divide into three main geospheres: the core, the mantle, and the crust. The separation process was caused by differences in the density of the materials. The denser the matter, the deeper it sank into the bowels of the planet. There's a core in the center of our Earth. The core consists of heavy metals such as iron and nickel, and it has a temperature exceeding 5,000 degrees Celsius. For comparison, the temperature of molten iron, which we can see in the form of lava, is about 1,200 degrees. The next layer is the mantle, which is the layer located between the crust and the core. Imagine the Earth as a cake with three layers. If the crust is a thin upper crust, then the mantle is a thick middle layer. The mantle is much thicker than the crust, and it consists of minerals such as olivine and pyroxene, which are lighter than those found in the core. These minerals are similar to sand or clay, but in a hot and viscous state. There's another important property of the mantle. Despite its high temperature, it does not melt completely, but remains semi-solid. This means that the mantle can move slowly, and it creates plate shifts or volcanic activity. And finally, the bark. A thin outer layer formed mainly of silicate rocks, such as granite and basalt. In Croatia, granite is a light rock that can be seen in the mountains, and basalt is a dark and denser rock that occurs on the seabed. After the Earth cooled down a bit and the layers of the Earth stabilized, its atmosphere began to form. In the early stages of atmospheric formation, its main components were hydrogen, methane, and ammonia. These gases created an aggressive and dense atmosphere, very different from what we see today. For a better understanding, imagine a volcanic eruption. When a volcano spews lava, smoke, and gases, a dense and aggressive cloud layer forms. These gases create an atmosphere in which it is difficult to breathe and live. This is something like the early atmosphere of the Earth. But it wasn't that bad for long. The aggressiveness of the atmosphere began not only to cool the planet, but also to form a climate that changed over time and became more stable. Gases released from the bowels of the Earth created an atmosphere that continued to evolve over millions of years. We also remember that our Earth consists not only of the lithosphere and atmosphere, but primarily of the hydrosphere. If you'll just give me a minute, our Earth today consists of about 71% water. So the appearance of the first oceans is important in the process of formation. As the Earth cooled, including due to condensation, the first oceans began to appear. This happened about 4,400,000,000 years ago. Water, which previously existed as steam in the atmosphere, condensed on the cooling surface of the planet and formed the first reservoirs. If anything, condensate is water that forms when moist air cools down and turns into liquid. For example, when you hold a cold bottle in hot weather, water appears on its surface. This is condensation. But don't think that the oceans have appeared the way we can see them now. Initially, the oceans were highly acidic and contained dissolved minerals and elements. Due to the effects of volcanoes, this made the water very aggressive and unsuitable for life. But the aggressiveness of the water, as well as in the atmosphere in the future, influenced its evolution and stabilization. The result of differentiation after cooling and the formation of layers, the Earth began to take on a more stable appearance, which created the conditions for further evolution. It's not the same burning ball in space anymore. Water, atmosphere, and the first geospheres became the basis for the subsequent appearance of life. In short, when the Earth first appeared, it was very hot, just a ball of lava. Gradually, it cooled down, and three layers appeared: a hot core inside, a mantle in the middle, and a hard crust outside. Then gases appeared. That's how the atmosphere was formed. At first, it was poisonous, but over time it became softer. As the Earth cooled even more, steam began to turn into water, and the first oceans appeared. They were also aggressive, but then they became calmer. This is how the Earth turned from a fireball into a planet where life is possible. That's it. In the following chronological video, you will learn how our planet was formed further. Wait for the new video.